AtCoder contest for 413. So basically कितने लोगों ने contest दिया है शुभम को छोड़ के, बताओ जरा। हाँ उत्कर्ष, कितना किया सॉल्व?
भैया 3 क्वेश्चन क्या था, वो थोड़ा बाहर जाना था इसलिए 3 किया।
अच्छा, ओके, 3 मतलब पहले 3 ना?
हाँ भैया।
अच्छा ठीक है फिर। सो डोंट वरी, अभी सारे करेंगे तो तुम्हारा सॉल्व भी हो जाएगा और एक्स्ट्रा दो। तो अभी so we will start from there, from the first question, that is the content too large. Okay, so first we will read the question properly, because the halfway to solve the question is to read it properly. Okay, so the question says, Takahashi has n items on the bag, on and one bag. Okay, so there are n items and one bag. The size of ith item in is ai and the size of the bag is m. Okay, and if and only if the total size of the items he is trying to put in the bag is at most m, he can put all those items in the bag simultaneously. Okay, so what he is saying, that he will put all the items simultaneously in that bag if and only if it satisfies the condition, that is that the total size of the items must be in the range of in, or you can say must be less than or equal to the size m. Okay, if he can put all n items in the bag simultaneously, print yes, otherwise print no. So basically we just have to check that if we can put all the items simultaneously in the bag or not. Okay, so if we see, let's say the length, that given n, let the n may be 5, m may be 16. Okay, so what does it say, that there are n items, that is 5 items, and there is one bag that's maximum occupancy or maximum size is that its size is 16. Okay, so let's say the items are with the size 4, 3, 1, 2 and 1. Okay, so basically what we have to check, that if the total size of all the items is less than or equal to m or not. Okay, so what I will do is, it is obvious and it is so easy. Any of you just say that what we will do now here.
Find the sum of the array. If it is less than equal to, then print yes.
Yes, obviously. So what we will do, you will initialize a sum variable that will be initialized to 0. Then what we will do, we will iterate all over the array. Okay, and we will do sum plus equal to array of I. Okay, so and array of I, that means the size of that element at index I. Okay, so what after the iteration, what we will have the total sizes of the all elements. Okay, so that is in the sum. So now what we have to check, if sum is less than or equal to that m, that is the maximum occupancy of the bag. Okay, so if it is true, then what we will do, we will just print here yes. Okay, and if it is false, then what we will do, we will print no. Okay, so this is so easy and easy to code also. So uh, if I make you see the code actual, okay, so that will be see for once. So this is the code of the first question. So that is that we are taking input n and m, and we are initializing the sum variable, and then we are getting the sum of total elements of the array, and then we are checking this condition. If it is true, then print yes, or if it is false, then print no. Okay, so is that clear, or any question? Okay, so we can proceed to our next question. So this is our next question. Okay, so our next question says that you are given n types of strings. Okay, that is s1, s2, and dot 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 sn. Okay, and you perform the following operation once. So you can perform that operation, and only for once. Okay, so what is it? It is that chose distinct integers I and j, that I is in the range of 1 to n, and j is also in the range of 1 to n. Okay, and concatenate si and sj in this order. Okay, so in this order means that first the if let's say the concatenated string is str. Okay, so it's so si will be its prefix part, and sj will be its suffix part. Okay, so in this order, si plus sj, in this order we have to concatenate them. Okay, so how many different strings can be obtained as a result of this operation? So we have to tell that how many unique string we can obtain by doing that you can say operation, or and if different choices of I comma j results in the same concatenated string, it is counted as one string. Okay, so basically what that if two strings, let's say there is a string uh, uh, str1 str2, and there is a string str3 str4. Okay, so if str1 and str2 concatenation makes the same string as str3 plus str4, then it will be counted only once. Okay, we will not count it as twice. Okay, so and there is the constraints that n must be greater than equal to 2 and less than equal to 100, and n is integer. Si is a string of length between 1 to 10, and inclusive. Okay, and consisting of lowercase english letters. Okay, and si is not equal to sj for I, and so basically it tells that there is no duplicate strings, okay, in that array. So how we should proceed? Can anyone say? Just raise your hand and
Yes,
say.
we can use a set of strings, and we will be storing all the possible strings after concatenating, and we'll be returning the size of the set. And it
Okay,
is the
so
answer of the question.
okay, so you are telling right that we will be doing that we will be generating every possible you can say string concatenation, permutation and combination in that case, and we will put it in a set. Okay, so what a set does, a set does that if I
Unique.
make you see. So basically, what a set does, if it is a set, okay. So if we first put it there, let's say cat, okay. So this is cat. If we again try to put there cat, so what it will do? It will not take the new cat as an different entity, but it will just see as a duplicate of a pre-existing value. Okay, a pre-existing element in that case. So what it will do? It will not consider the duplicate elements in its size, or you can say it. It will just keep the unique values it will get in all over its okay. So if we insert all the possible combinations of the you can say concatenations of the strings, so what it will do, it will just consider only the unique ones. Okay, so now what we can do, we can, let's say if we are taking a vector of strings. Let's say this is the vector of strings, and there are string s1, s2, s3, s4, s5, s6. So basically what we will do, we will generate every possible you can say concatenations of by using any two of them at a time. Okay, so now what we will do, we will just, let's say if this is our first string to be concatenated, so what can we choose as our second string? We can choose this and this also. Okay, so basically for one choice, that is the first choice of our first part of the string, that is s1, we can choose these four different you can say five different another strings, okay, to concatenate. So basically in that case, the concatenation will be like that: s1 plus s2, or s1 plus s3, or dot 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 s1 plus s6. Okay, so but here is a twist, that whenever we are making this type of type of concatenation, then we have to consider again that there can be also reverse combination. Okay, so what is a reverse combination here? That is, if we are concatenating the strings s1 and s2, we can concatenate it in the order s1 first, s2 second, and also s2 first and s1 second. So same for this also, that s3 first and s1 second, and for this also s6 first and s1 second. So basically for each and every pair we are getting from that from traversing the array, we will take the two type of concatenations. That is the first part will be let's say s1, and second part, if it is s3, then s1 plus s3, and as well as s3 plus s1. Okay, and we will put both of them in that set. Okay, so that's how if we do this, so basically for this case it is done. Okay, so now what we will do, we will now go for this. Okay, so we will consider it as the first string to be concatenated. So now which strings can be concatenated with it to make new strings? So you can say that this this and this, but we will not consider it here. Okay, because why? Because when we were considering that s1 to be s1 with s2, s3, s4, s5 and s6, we have also considered s2 plus s1. Okay, so in that case, when we are considering for that s1, we already considered that the pair s1 comma s2. Okay, so s1 is not in our consideration all over for now. So for now what we will do, we will just see forward from this index. Okay, so it is the index 1, so we will go forward, and let's say s2, and now the concatenations will be s2 plus s3, s2 plus s4, and dot 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 s2 plus s6. Okay, and same as before, we will also considering s3 plus s2, and s4 plus s2, and as well as s6 plus s2. So basically can you see that what we are doing actually, we are actually traversing the array of strings in a nested manner. Okay, in a nested loop. So basically what we are doing, we are first considering a string as the first part of the concatenation. Okay, and we are traversing the whole array, you can say, or at the forward part of the index. Okay, and then we are making all the possible concatenations and its combinations, and we are putting it in the set. Okay, so basically when we are putting all this in that set, so what the set will do, as I mentioned earlier, that the set will consider only and only the unique strings. Okay, or the unique concatenations also. So basically the set here will manage all the things, that is considering the do not considering the unique sorry, the duplicate values of the strings that are concatenated, Okay, so basically, the main problem which we are facing, that uh, why when not to consider the duplicate values, it is solved by the set. So basically, now we are okay that what we will be doing. We will be traversing the array in the nested loop, and we will generate all the possible concatenations, and we will just put it into the set. And after everything we have done, what we will do, we will just check that set, let's say set dot size. Okay, so that will be our answer. So after all the making all the possible concatenations and putting it into the set, uh, now the total number of unique strings that are in that set is our answer. Okay, is there any confusion, any query you can ask? Okay, so basically what we will do, we will just as I told you that we will traverse the string. Let's say if I write the pseudo code, we will do a for loop. Let's say int I equals to 0, I is less than n, and I plus plus, and again another for loop, that is int j equals to I plus 1 to j less than n, j plus plus, and let's say there is a vector string, that is str. So basically now what we will do, we will put there is also set uh, if I make a space, set string st, then we will put st dot insert str I plus str j, and again what, again we will just insert st dot insert str j plus stri. Okay, so basically what I have said you earlier, that I am doing here. So we are generating all the possible concatenations and we are inserting it into the set, and after the whole traversal is complete, so we will just print that what we will print, we will print the size of the array. Okay, so that will be st dot size. Okay, so now if I show you the actual code, it will be more clear to you. So this is the code. Basically what I am doing here is, as I mentioned you earlier, that we are taking n as into input, and then taking str as a vector and set st, then we are taking inputs, and then we are doing the nested loop thing. Okay, and as I have mentioned, and as we know, basically I have put here this line, that is if stri is not equal to strj, you you if you want, you don't have to do that, because we are given already that stri is not equal to strj for any possible combinations of I comma j. Okay, so basically if you don't do it here, or don't write it here, then there will be no problem also. So basically now what is there is the main thing, that we are inserting it, the possible combinations of concatenations, that are stri and strj plus strj, and then strj plus stri in that set. And after all the traversal, we are just printing the size of the set. Okay, so is it clear now, or there is any query? Okay, so now we will be proceeding for the next question. So this is the next question, that a large queue. Okay, so there is an empty integer sequence A. You are given q queries and you need to process them in a given order. In the given order, there are two types of queries. Okay, so there are two types of queries that are type 1, given in the format 1 c and x, and add c copies of x to the end of A. Okay, so what does it mean? That we have to keep the c x c for c times. Okay, that is c copies of x, just. Okay, then type 2 query, that is given in the format 2 comma k, remove the first k elements from A and output the sum of the removed k integers. Okay, and it is guaranteed that k is most of the length, it is at most length of A at that time. Okay, so basically this line, what this line means, so this line means that every query that of type 2 will be valid. Okay, so there there will not be any query there where you can say that it will go out of bound, that k will be more than size of A, that will give us wrong answer. So it will not happen. Okay, so there will be always a valid query. So now the constraints is that q is greater than equal to 1, less than equal to 2 into 10 to the power 5, and as they are mentioned, there is just the ranges of the values c, x, k, and all these things. Okay, and all input values are integer. So if you want to see how the inputs and the queries will be given as an input format, so this is the type, that first there will be given n, that is the number of queries. Then there will be given the, you can say, how can we check that is it a type 1 query or type 2 query. So first we will just take input the first number. Okay, if it is 1, then we will take input of two numbers. Okay, and if it is 2, then we will just take input for one number. Okay, so basically thus we will make difference for the query 1 and query 2. Okay, so now uh, if we see the how we can solve this, so basically how many of you have solved it? Okay, just raise your hand and share your
Yeah, I
approach also.
tried, but using sliding window and prefix sum, but it was throwing clearly due to higher constraint. So didn't solve it.
Okay, sliding window and prefix sum. Okay, na. Okay, yeah, it must do TLE because as there we cannot store, you can not literally store the x, you can say c copies of x, because c can be as large as 10 to the power 9. So if we start to store that, like uh, you can, if you say that the first query, that is the query 1, is taking the time of big of n, sorry, or big of, or you can say c, that c copies we are putting it into that, you can say array, or anything you are using, so it will give TLE most probably. So Utkarsh was also raising his hand. So Utkarsh, can you say your approach?
Yeah, I did the same thing first. Then it gave clearly. And what I did was store. If it was case one, means when n was equal to 1, then I
Hmm.
stored c and x as long as a pair
Yes.
inside inside that. I forgot what I did, but I stored it there. In that step, I didn't do anything. But after, if it was k's entry, then I took in k. If c was less than, till I found the c, I computed it in the sum, and also the sum will always be less than 10 to the power 18. That is long's range, because it is minimum of 10 to the power 9, and a of I, that is 10 to the power 9. So it will be 10 to the power 18. So
Yes.
that's what I.
Okay. So now if we just proceed to that question, so basically for the query that is 5 1 2 3 1 4 5 2 3 1 6 2 and 2 5. So basically if we visualize that input test case, so what we will see, this is the query one. Okay, so here let's say this is a first, it is empty. So after the query one, it will become like we want 2 times to be inserted. Okay, so basically it will be like that 3 3, and then after the and again and another first query, query one, that is we have to we have to make 4 copies of 5. So we will put 5 5 5 and 5, and then for the query type 2, that is 2 comma 3, what we will do, we will just uh, take the first 3 numbers from here out, and thus we will also just return the sum of them. Okay, so the sum is 3 plus 3 6 plus 5, that is 11. So we will just print 11 and we will delete that part, okay, from a. So firstly, the basic and naive approach you can think is that we will sir, bhaiya, ki we will just take a as a string, and we will do as mentioned, that we will store all c copies, like I have stored that 3 comma 3 3 and
Yes,
5
Bhaiya.
5 5.
Excuse me, Bhaiya. I
Yes,
remember
yes.
I stored this pair of long inside the queue. Then after the C was done, checking I means K was done checking, I minus it if it was less than C, and same stored in the iterator of font of first. That was the thing I did, as you said.
Okay, okay, okay. So it is okay. So basically, that is the correct approach also. So now, if we see here, so basically, what we cannot do, we cannot store the values like that. Ki we will be taking a string, or we will be storing the all copies of you can say all copies of x for c times. So we cannot do this because if we do that type of thing, then let's say there it is. You can say uh, 10 to the power 9 copies of 3. Okay, so in that single operation, what will happen, that you have to store 3 for 10 to the power 9 times. Okay, and what we know, that our time complexity must be uh, like that, key we have to do it in the time constraint of 2 seconds. Okay, so basically what does it mean, we have to do it under the 10 to the power 8 operations. Okay, so it is all upper bound, so we cannot do a operation that itself will take 10 to the power 9 or bigger, you can say, time complexity. Okay, so what will be a better approach or a smarter approach, that we will store this thing, that x comma c, x comma c, we will store it as a pair. Okay, so if we store it as a pair and in a queue, because of what we are seeing here, that we are inserting at the from the behind side of the you can say string, or you can say array, if anything, or you can say the sequence also, and we are deleting it from the front side of the sequence. So basically it matches its characteristics with a certain type of data structure, and that is queue. Okay, and it is obvious from the question also, the question name also suggests a large queue basically. So we will be using a queue data structure to to do our operations here, and to manage the frequencies and the elements, okay, in that sequence. So basically in that first operation, that is the query one, what we have done here, we have done that we will just put 2 copies of 3 here. We rather than doing this, what we will do, we will just, let's say, q is the q, and we will be putting a pair, that is 3 comma 2 here. Okay, so basically we are putting that pair q like that, the first element, that is the value of element. Okay, and the second thing, that is the frequency, the contiguous frequency of that element. Okay, so that's how we will store our you can say our queries. So basically, if we do it here, so first, after the first operation, the queue, we will see the queue as you can say 3 comma 2. After the second operation, we will see 3 comma 2 and 5 comma 4. After the third operation, we will see as after the third operation, what we will do, we will take out the first three elements. Okay, so as we are taking the first three elements, what we will do, okay, so we will be checking through the queue. Okay, and we will be deleting every element that is you can say to match the condition that we have to remove the k elements. Okay, so basically first we will come here, that at this point, so we will check what is its frequency is 2. Okay, and it is less than 3. So basically at any cost we have to totally remove it from our queue. So what we will do, we will just pop it from the queue. Okay, so then what will be here, 5 comma 4. But again, there is also one element to be removed. Okay, so we are not done yet, so we have to remove it from this pair. Okay, so if we remove it from this pair, so now what the pair will look like, the pair now will look like 5 comma 3. Okay, so basically what we have done, we have just decreased the frequency of that element, as the frequency of that element was higher or bigger than the amount of elements we need. Okay, so as we need only one element, so what we will do, we will just pull out that one element, that is the 1 5, and we will keep the rest of the things as it was. Okay, so basically after third operation, our queue will look like that. After fourth operation, what is the fourth operation, that is the type 1 query, that is we will put again 6 copies of 2. Okay, so basically now what it will look like, 5 comma 3 and 6 sorry 2 comma 6. Okay, so this will be a queue looking. And now the last operation, the last query, what is it, it is type 2 query, that we have to take out 5 elements. Okay, and what I have forgot to tell you, that here, as we were removing it, this and this, we are doing these operations, we have to also store the sum of the all elements. Okay, so as we have taken the whole this thing out, so what we will do, we will just make sum plus equals to that this first part into the second part, that is the total sum of the total part. Okay, so that is 3 into 2, and plus also that we are taking one element of 5, value 5, so 5 into 1, that is our 11, and we will be printing at that time also. And here, as our last operation, what we are doing, again that we have to take 5 elements from the front. So we will come here at first, and we will see that there are only 3 elements of value 5, and we have to take out 5 elements. So we are certain about that we have to totally take out this pair. Okay, so as we have to take out this pair, we will just pop it out, and we will add in sum, and at every time we just have to initialize the sum as 0. Okay, for the second type of query, so we will just add the sum in 5 into 3. Okay, and again we have to go there in the next part, and what we will check again, that now uh, how much amount of element are left out to be taken. Okay, so firstly there was 5 element to be taken, now 3 elements we have taken already, so now it is 5 minus 3 equal to 2, so we have to take 2 elements more. Okay, so now we have 6 copies of 2. Okay, so there are 6 element value of 2, then and we need what? We need two elements only. So basically what we will do, we will just decrease its frequency by 2. Okay, so it is that 4, and we will just keep all other things as same as it was. And now our sum will be again plus equal to, that is 2 into 2. Okay, so now the what the sum will be, the sum will be here 19, and it will print that. So what are the results or the outputs? That are 11 and 19, and these are the actual output we need. Okay, so can you see now that what we are doing actually? And can you tell any of one of you can tell the pseudocode how we will write this logic in the code format? Just raise your hand and you can tell also. Okay, so basically what we will do, we will just first make a queue. Okay, queue of pair, and the pair will be of long long. Okay, let's say LL. Okay, Kumar, Utkarsh have raised his hand. So Utkarsh, you can continue if you want uh, to explore. Uh, so tell me how we will code this. Okay.
Yes, we are first. We'll make a queue of long long, as you said.
Yes. Let's say we are type
Then
defining long long as LL for our. Okay. So just now tell what we will do now.
then take in uh, we'll take in C means Q, so that we can check Q number of operations.
Okay. So we will be taking input as Q, and we will be doing loop I equals to 0 to I is less than Q I plus plus, and then what we will
Then
be doing
after
now?
uh, for Q number of operations, we'll first state for switch statement either switch case one or case two. We'll take a variable n or
Yes.
anything.
So we will first check for case. So as we have checked for case, if the case is 1, there will be a code, and otherwise else there will be a code. Okay.
Yes, we are.
So now just tell me what will be the code for this case, for case 1.
Case one will be we will take in C and X, seeing C and then X.
C and X. Okay. So now,
And for Q, we will push the pair of X comma C.
okay. So we will push just pair of X comma C. And for this case, what we will do?
Uh, for the other case, we will take in K. First, we will take in K.
Hmm.
Then make a sum equal to 0. Means
Yes.
we'll form a sum equal to 0. And for like K operations,
Hmm. So while we will do the while loop, that while k is uh, greater than 0, because you can say now that how can we be so sure that if we do the while loop according to the k, that it can surpass the q, or you can you say that it will be giving the index out of bound. It will not happen here, because we are said here already that the every given query will be valid. Okay, so basically you don't have to consider about that.
K is
You,
less than 1.
yes, so now what we will do?
Then we will check. Means we can store in any value. Front first, Q's front first.
Okay, so
Value will be there.
let's say q is the q dot front. Okay, so now what we will check? We will check is q. dot second, is it less than or equal to k or not? Okay, so if it is less than equal to k, what will happen? Just tell me.
We will do just the sum, means take the sum as total of 0 plus value into count, because it is less than total of k.
Yes,
And then
sum
we'll
will be
update the two,
q dot first into q dot second. Perfect. And then what we will do?
and then we'll update the k's value to k minus count, means or frequency.
Do you think here we need to update the value because already the q
Not,
dot second is
it's
less
not
than k?
necessary. It's not necessary. I was doing it for second time. That's why by mistake did it.
No, I am saying that can we just pop it out? Because we don't need now, because the second part, that is the frequency of that element, it is less than equal to k. So basically we are sure that we don't need it, we have to delete it from the queue. So should not we do it as q dot pop?
It is not necessary. The second is q k will be equal to 0 till then. So we need to decrease it. After that, we can do q dot pop.
Yes. Oh, okay. Oh, so you are just telling that we have to decrease the q, na?
K,
Okay, just k. Yes. So we have to just make
and
k
then
minus
q
equal
dot
to.
pop.
Okay. So yes. Okay. So that is okay. So we will do second and then q dot pop. Okay now. So and else if it is greater than, then what we will do?
We will do the same thing, but value into k, because k is smaller than frequency, and then
Hmm.
update the front of second, means the count inside the queue, uh, to be less, means equal to minus k. Whatever
So
it is
we will
there,
do
it will
this,
be
and we will do that is the front as qu dot second as minus equal to k. Is that okay?
yes, where I was.
Yes, and just
And we
k.
also update k to 0,
Yes, just this in this part, just you can say k equal to 0. It's okay.
or we can
And
even
thus,
use break or anything.
yes. Also same. That will be same also. So after that, what will happen? We will be getting the sum value after the whole iteration, and we have to just print south, that is sum. Okay. So is it clear now to all? So we will just see the actual code. So this is the code as I showed you, as I have written already in the pseudocode format. That is, we have to take the queue as query, and then taking that the type of query, that is queue, and if it is one, then we are pushing it as that c comma x, as it here c comma x, and uh, then what I am doing, while k is greater than 0, we are just putting we are doing the while loop, and if while k is greater than equal to query dot front comma first, and some plus equal to that q dot front comma second into first, and that this thing. And how I have written the code as for you, I have taken the pair as first as the value and second as the uh, frequency. But in this code, in my code, I have just keep it different, and you can keep it reversed from that. I have just stored first the frequency and then the value, and nothing is other than it different. It is okay if you store the value first and the frequency second, then just you can exchange the second to the first and first to the second. The code will left out will remain same, and this thing also, and this, and after the whole iteration of a while loop, we will be getting the sum and we will be printing it. Okay, so is it okay now? If any query or question is arising in your mind, you can say. Okay, so we can now proceed to our next question. So it is our next question, that make geometric sequence, that is you are given an integer sequence a, that is a1 a2 dot dot an of length n. It is guaranteed that for any I, that I is in the range 1 to n, ai is not 0. Okay, and determine there whether there exists a permutation b, that b1 b2 dot 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 bn of a, such that b forms a geometric sequence. And the sequence S is a geometric sequence if there exists a real number R such that Si plus 1 equals to R into Si. So basically, you know what is the geometric sequence. A geometric sequence is that there is a first, or you can say starting value, and there is a common ratio. Okay, and thus it forms a series that, let's say, if the starting value is a and the common ratio is r, then the series will be a, then ar, then ar square, and then ar cube, and all this thing. Okay, so basically we have to tell it now that if we can shuffle the array a, or the integer sequence a, in a certain you can say in the certain way, that it forms a geometric sequence, that is the b. Okay, so if it does, and this is the constraints, you can see these things also, and if it does, so then what we have to put, we have to print yes, and if it doesn't make any sequence like that, then we have to just print no. Okay, so can you say what will be the most naive approach, or you can say the brute force of this thing? How can we proceed in that question? You
Yeah,
First,
can
what
we
I
can,
thought of.
yes, tell.
first we can sort the array, and
Yes.
we can check the geometric progression relation on each the element from the front side and back side also, but it is not working due to, because we
Yes,
can some
it
players.
should not be working also. Have
Yes.
you find out that in which test case is it is not working? Have you
Yes,
find
like
out?
Like
plus minus that thing. We
So
should
basically,
we
just
should
say yes,
sort
yes,
on
just
the
say
basis of absolute.
hello, Utkarsh, your sound is not coming well.
Yes, but I was saying if we can sort on the basis of absolute value of the numbers,
Yes, we
think
have
of
to do
like
that. Yes, but why we
then
have
it
to do that?
will work.
First, we have to check it. Okay, so if we take a test case like that, let's say the test case is you can say -4, comma 16, comma uh, 4, and again 6 -64, and then again 4 256. Okay, so now Shubham, just tell me that what will be the sorted order, okay, for this thing, and
Minus
according
4,
to your
minus
approach will
64.
it be
Yes.
okay. So just it will be -64, -4, 16, and 256. So now tell me, according to approach, it will give yes or no?
It will give no.
No, na.
Yes, no, it will give no.
It will give no according to your approach, because you are sorting it according in the normal form. Okay,
Yes, yes.
so but if we if I make it like that, as I have mentioned here only, that it is, or you can see here only, that if we check it here, just go from here to there, that minus 4, 16, minus 64 and 256. Just see it through thoroughly, and you can see the pattern that it is itself a GP series, where the A is minus 4 and the common ratio R is minus 4 also. Is it clear now?
Yes, we.
So basically, there is an the first observation that we should have to see here, that we cannot sort it according to the according to its value only. Okay, because if we sorted it in that order, then we will be missing the actual sequence, or you can say the actual order, as we have missed here. Okay, so and what we are sure about, if it is a GP series, and then what will happen, either it will be decreasing, and either will be increasing gradually. Okay, let's say we are taking the increasing part. Will be sorting in a certain type, that we will be getting the increasing, but increasing at which parameter? So we have to find that out. So if we see it here, in that case only, so you can see it that if that the common ratio is either minus or either plus, it can be anything. But if our common ratio is greater than 1, then it is obvious that the next number, that is the 16, that is the next number of 4, it must be it will must have a greater absolute value than its previous number. Okay, so it is obvious, and it is the constant thing here. So basically now you should have to strike in your mind that how can we sort that thing. Okay, basically how can we sort that array, that we can get our you can say our actual order, or the probable order that can be forming the GP series. Okay, so now is it clear that why we are will be doing the sorting according to the absolute value, or
Yes, we.
any doubt?
Understood.
Okay, so now it is understood that we will be sorting it according to the, you can say, uh, as already I have said, that according to the absolute value. Okay, so now after sorting according to the absolute value, it will remain same, that is 64 and 256. Okay, so now you can say that now we have sorted it in that order, and now what we will check, we will just check that it is it forming a GP series or not, and what is and how can we check it is forming a GP series or not. Let's say it is a number, we can start checking from here, and we should be finishing it sorry, we'll be finishing it here. Then let's say these are the part of GP series. Let's say A, B, and C. Then what will it should obey the thing, that is B square
C
equals to
into A.
that thing. Yes, B square equals to C into A, or AC. So it should abide by this condition. And now we will check this thing for all the elements there. Okay, so if it satisfies it, we can say it can be a you can say a GP series. But there is a twist, that there can be a another sequence where your logic, that is, now that logic is that we are sorting the things as according to its you can say absolute value. But if we see that the array is minus 4 comma 4 comma 4 comma minus 4. So now just tell me what will happen, what should be its answer. Should it be answering yes or no according to our new logic, that we will first sort it out according to the absolute value, and then we will check for every element, that is it uh, doing this thing or not. Just tell me. So basically, if we see here, as we are sorting it according to our absolute value, as Utkarsh said according correctly, that we are sorting it according to the absolute value. So if we sort it there also, then will anything change, or it will be remain same, that in that order also, that -4 will
It
it?
will remain the same. That will be a
Yes,
problem.
yes, that will be the edge case, that it will remain same, but we can do what, we can make it like -4 comma 4 comma -4 comma 4, or either 4 comma -4 comma 4 and -4. Okay, so basically these two possible combinations are, or permutations are possible. So our the new you can say the type of sorting we are doing here is not worthy for that edge case. So what we have to do, we have to handle this edge case in a different manner. How can we handle this edge case? Can any one of you say it by raising your hand?
Bhaiya, we
Bhaiya,
can do like
can, can we
Okay,
take
okay.
R equal to like division of next element upon previous element, and we'll be checking through all the array?
uh, if you want to see that R thing, that is the common ratio, but we you what type of it you will be taking, double or integer or long?
Long double, because it is
Yes, long
this
double na.
value.
But
Yeah.
the long double can also give you the wrong answer, because there is a
Yes,
thing
yes,
called
yeah. We
yes.
can
So you,
also check through reverse order, because we have to check in both orders.
yes, reverse sort also, but you are, if you're telling it like that also, then what we will be doing according to you, we will be sorting it according to our absolute value, or normal sorting.
Absolute value, absolute value.
Okay, so after absolute value we are getting this, and if we take R, so for first thing the R will be -1, for the second thing, for the second the R will be +1,
No, yeah,
and there
not this array. Previous array, like the 416, that array.
which array?
416 array.
Okay, 416. Now, okay. So basically, you are talking that why we are not doing the R tribe. Okay, that is
Yes,
na. That is your question.
yes, yes,
So basically, we are not taking as long double also as R, because there is a thing called floating point error. Okay. So what is a
okay.
floating point error value? That if we are doing a division operation in a in a number, then after sometimes at, you can say, as a 10th decimal place or 18th decimal place, there will be some error. Okay, so basically what will be there, that let's say 17 by 3 is something, you can say the 3 5s are 15, and you can say 5 comma 6 6, and you can say 6 6 and up to something, and again you are doing that same thing, 7 by 13, that the double long double division. Let's say it can also happen that it is coming there it is coming 7 at a 17th decimal place, and here the 7 is coming at the you can say 20th decimal place. So basically what we will do, as the both are same, but it will consider as these things as a different value. Okay, so now that due to that floating point error, you will get the wrong answer. So is it correct to now to you, that why we will
Yes,
not do
yes.
this thing?
Understood. Yeah.
Yes. So basically, we will be doing this thing only. And now, if we continue here, so basically, we are facing the problem. We are facing the problem at the edge case, that if all the absolute values of all the elements are same. So how can we handle it now? Can you say?
Bhaiya, we have already sorted the array.
Yes.
So absolute values. So we can check if A0 is equal to n minus 1. Then after that, we can check if there exists means total number of half minus or half, means we can check if there is an alternating pattern. In that sense, we can check it.
Okay, so we don't have to check the alternating pattern, because after sorting also we are not getting the alternating pattern, that is minus 1 plus 1 minus 1 plus 1. So
Or
what we have
one
to
more thing you
check?
can do,
Yes, if we
we
have to
can
check
also
if
sort
we
the
can
normal
form the.
array.
Yes,
We
yes,
can
yes, just
sort the
tell.
normal array and then check the middle one. If it is less than zero, then half will be less than zero, and half will be
Uh,
plus. Then that will also work.
yes, yes. So basically, you actually don't have to sort it actually. So what you will be doing while taking the input also, let's say in that for loop where you are taking the input array or I, so you just keep two extra you can say variable, that is positive variable and negative variable. Okay, so what we will do, we will just store the you can say increment the value of these variables. If it is the array I is positive, then we will just increment the positive variable, and if it is negative, then we will be incrementing the negative variable. Okay, so after that thing, and we also will be checking that the if uh, you can say, let's say there we can take also a set that we it will be storing all the values to check if all the elements are equal or not. Okay, so basically if all the elements are equal, or you can say or let's scrap this. You were what you were telling, just you tell that your thing was also right.
I was telling that we already have a sorted array. Then we
Yes,
can
yes,
check if all elements are same by checking one condition: a0 is equal to a n minus 1. Then we can sort the normal array,
yes.
which has the normal values, and then we can check the middle a n by 2 half. If it has means less than, if it is less than 0 and n plus 1, n by 2 plus 1 is greater than 0, then we can say that it has equal number of alternating elements. That
Okay,
was applied.
if there is not equal number of alternating elements, then can it be a sequence also? Let's say there are
It
three
is
negative
like
value and two positive value.
plus, it can be, but then also the middle one, there will be a thing like it can be at max, means n plus 1 by 2 only, I guess.
Okay,
As
so
you are saying,
basically,
minus plus minus can exist. Plus minus minus can also, like, alternating can also exist, and
yes.
one extra can
uh,
also exist.
yes, yes. So basically you are telling that alternate, in that case we will be first checking that uh, here after sorting there we will be getting minus 4 minus 4 minus 4 4 and 4. What we will be checking now, just tell me.
A0 is equal to a n minus 1.
Yes, only the absolute value. Is absolute value of a0 and of minus 1 equals to, are they equal? Okay,
Yes.
so after that what we will check now.
We will check the middle, whatever the middle of the array is. Here it is
Hmm.
5, then that will be 2. So if we will check that if greater than 2 exists, there are equal number of, means number same thing, and if less than 2 means 0 and 1 decimal places equal, it is there, then it will be a GP. It was that thing I said. Means
Okay, let's say the array is this. So now what will, according to your algorithm, what will be answer? Yes or no?
no, it will be no, because I will check except
Hmm.
the middle element. I am checking the last two. Number of last two elements should be less than 0, and I am checking if the first to think if the number which I am saying is index 1 is not less than 0, then the total number will never be less than 0 because it's already sorted.
Yes.
That's the thing. And the first two is 5 and 6, sorry, 3 and 4, they are there. So it won't be compensated equally. That's what I was saying.
Okay, so now just see a simple thing. if I say that let's say there is a number positive equals to 0 and negative equals to 0. Okay, so here we are storing the number of positive values, and here we are storing the number of negative values. Okay, so let's say there here it is positive value equals to 4, negative value equals to 1. So if I put a condition that if absolute of positive minus negative is less than equal to 1, then in that case that we will be print yes, or else we will print no. Is there any problem? Can you see now, after checking that all the elements, all the absolute value of the elements are same, so we are just keeping track that how many positive number and negative numbers are there. So and then we have came to a thing that if the difference, absolute difference of positive number of elements, positive and the number of negative elements is less than or equal to 1, then it can form a alternating GP series. Is it okay?
Yes, bhai, I think that is okay.
Yes, you can just take and check for any element. Let's say the element is 8. Let's say the number of positive number positive is 4, and number of negative is, let's say, 3. So can you put it like 8 comma minus 8, 8 minus 8, 8 minus 8, 8? Is it okay now? Is it okay?
Yes, bhai.
And if we just make it negative element as 5, so what sorry, let's say we are making it negative element as 4. So what we will do, we will just again put it here. So there the series also remains intact. And if we make a negative element as 5, then again we have to put it at the front, then again it is intact. But if we make it 6, that now the absolute difference of the positive and negative in frequencies is greater than 1. So now it will give it will give no or print no, because now we cannot make as alternating GP series here, because where you can say you can put minus 8. If we put minus 8 here, then it also be giving the wrong thing. If we put it here, then also it will be giving the wrong answer also. So basically there is a if in this observation you can see that if the absolute value of the difference of the positive the frequency of the positive integers and the negative integers is less than equal to 1, then and then only we will be printing yes, otherwise we will be printing no. And when we will check this condition, we will check this condition whenever all the absolute values of the whole array are same. Is it okay?
Yes, bhai.
And if you think that you are not sure about this thing, that how the absolute value of positive minus negative is less than equal to 1, then you can just try
No, bhai, yeah,
uh,
it's fine.
yes, you can say yeah, okay, then okay. Or otherwise you can just try and hit and trial case, we can say. So now if we just see the uh, actual code, so this is the actual code. uh, is it visible? Okay, so what we are doing here, as I said, we are taking n as input, then an array of length n, then we are taking as negative variable to store the number of negative elements there. And we are taking also extra a set to get if and we are inserting the absolute value of AI in that set, so that we can keep track that all the if all the elements in the array are having the same absolute value. And if it happens that is set size is 1, because all the uh, elements in that array are having the same absolute value, then we will be checking that if there are no negative numbers, okay, or there are all the numbers are negative, then also we can print yes. So I have missed it while showing you the code. So can you see this now? Is it okay for you that if there is no negative number, then every number is positive? So basically there the uh, you can say the common ratio is 1, and every number is negative number, then also the common ratio is common ratio is 1. Okay, so is it clear? So in that case also we will be printing yes. So now the next thing that I was putting that okay, absolute of positive minus negative is must be less than equal to 1. Eh, eh, Actually what I have done here, I have checked here that if there the length of the array, that is you can say even number length. Okay, so if the length is even number, then the amount of negative numbers must also be even. Okay, so then sorry, not even actually. So basically the amount of negative numbers must be half of the total number, so that is n by 2. Okay, if this thing holds true, and so we will print yes. Or if the length of array is odd number, okay, if the length of array is odd, then what can happen, then negative number may be the half of the array. Or you can say here the half means the, you can say the floor value of the division, that if the n is 5, then the n 5 by 2, that is 2 number of negative integers, that is 2, that also be giving us the yes value. And if the negative numbers are 3, then also it will be given yes value. And why it will given yes value, that I have shown you, that the condition that was absolute of positive minus negative must be less than equal to 1, that also conveys this thing, that when the when the, you can say the total length will be odd, then the absolute difference of the positive and negative integers, that must be less than equal to 1. Okay, so it can be 1 also. That this is the thing that caters that condition, and thus we will be printing yes. And if anything of these conditions doesn't hold true, then we will just print no, and we will continue. Okay, so now what we will do, now we will be sorting the whole array according to its absolute value. Okay, as I said earlier. So after doing this, what we will do, we will just check that thing, that is b square equals to ac, that for I 2 to n we are checking I minus 1, that is our b, that is b square, a I minus 1 into I minus 1 equals no, is not equal to ai into ai minus 2, that is ac. If it this condition holds true, then our flag, that is the our boolean variable, will make it false and just break from the loop. And if after the whole iteration, if the flag remains true, then we can say that it is a proper gp series. Okay, then we will print yes, otherwise we will printing no. Is it okay now, or any queries are there, you can ask?
No, bhaiya, no queries.
Okay, so basically these are the four questions to be solved, and there is a bonus question for us, that is the question number g. uh, Actually I don't expect you to solve it, because it is a hard, very hard question, but I want to share this question, the approach, so that you can start thinking for more tougher type of question that you can face in future. Okay, uh, so just let me be clear. Have you just read this question in during the contest or not?
No, भैया.
Bhai,
Okay,
no, bhaiya.
yes, it is obvious. So now if we read it, so read it carefully with me. that there is a H cross W grid. Let I comma j denote the cell at ith row from the top and jth column from the left. Okay, so each cell in the grid either has an obstacle placed on it or has nothing placed on it. There are k cells with obstacle cells that are R1, C1, R2, C2, and up to RK, CK. Takahashi is initially at cell 1 comma 1 and wants to reach cell H comma W by repeatedly moving to an adjacent cell up, either up, down, left, or right, that has nothing placed on it. Okay, and more precisely he can repeat the following operations as many times as he like. So this is the thing, you can read it, that if I is less greater than 1 and cell I minus 1 comma j has nothing placed on it, then move to the cell, and otherwise do not move. So basically what is this thing, that if you are not getting out of the grid, and if that cell at or you can say your destination cell, if it is not marked, or you can say it is there is nothing placed on it, so you can go there. Okay, actually so you can do that operation. And now what we will have to do, determine whether he can move from cell 1 to 1 1 comma 1 comma 1 to cell H comma W. That is the last you can say that the rightmost and the downmost cell. Okay, so this will be the input type H, W, and K. H will be the number of rows in the you can say grid. W will be the number of columns in the grid, and K will be the number of you can say cells where there is an obstacle. And there we will be given the, you can say, the I value and J value, you can say, or you can say the column and row value of the obstacle containing cells. Okay, so this will be the sample input. So you can see here also, this is the visualization of that thing, that what we have to do, we have to go S to G. And what we can do, we can go either up, down, right, or left. So let's say we are here. Okay, let's say we are here. If and for that, for this time only, imagine that there is no x or no x, or let's say if we imagine also that there is x also. So what will happen, that if from this part or this cell we can go up, we can go right, we can go left, we can go uh, sorry, you can go left, we can go down. Okay, and the second question is, we cannot go to the right or down here only for this cell. But why? Because the right hand cell and the down hand cell, they are having that cross mark that contains that they are containing some you can say obstacle. Okay, so and also if we are here in that position, we cannot go out of the box or out of the grid also. So basically if from a cell we can either go up, down, left, or right, if and only if we are not getting out of the grid, and there is not already a you can say obstacle occupying that cell. Okay, so the most and basic approach, can you think about how we can tell that can we reach from S to G or not?
Yeah, we can use
भैया
Yes,
BFS
yes,
traversal.
tell one by one.
We can like use BFS and check if the uh, position is marked with cross or not. And first, but like this can solve. We can solve the question.
Yes, yes, we can do the DFS traversal or the BFS traversal, and if we can check if it can reach to the G, or you can say the left, sorry, rightmost and the downmost cell. Okay, so but there is a problem. You can see if we see the constraints here, the H, that number of rows is 2 into 10 to the power 5, and the column are 2 into 10 to the power 5. So now tell me that what is the time complexity of the DFS or DFS traversal?
And square.
Yes, n square, or here you can say n into m or h into w, that is row into column. So what will be the order of the time complexity here? Just tell me.
10 to the power 10.
Yes, 10 to the power 10. So do you think it will pass in our time complexity, that is 2 seconds.
No, 10 to the power 8 is maximum.
Yes, so basically 10 to the power 8 is maximum. So we cannot do that DFS traversal or DFS traversal here, because if we do it here, then we will just get out of time, and we will get TLE. So we have to do something else, and we have to think in something another way, that can we do it in you can say in time. Okay, so what we are giving here, you can see, we are giving here that k inputs, and the k is also less than equal to 2 into 10 to the power 5. Okay, so basically what we will think now, we cannot operate on the actual boxes, you can say the actual cells in the grid. Okay, so what on what we have to operate, we can operate on the you can say the wrong cells, or the occupied or that obstacle placed cells. Okay, and we have to find, and we have to try to find that if by operating on that cells that are crossed cells, can we get the answer that if s can reach to g or not. Okay, so basically in that photo, can you see, can you tell me if s can reach to g or not?
No, Bhaiya.
Yes, so basically here you can see that s cannot reach to g, because if s goes there, then there it sees obstacle there and there also, here, there and there obstacle, if there then right hand side obstacle, there right hand side obstacle. Okay, so basically if we uh, if I show you by doing it, so this is the grid, let's say m cross n grid, and we have to reach there, and we will be starting from there. Okay, and we can go right, left, up and down, and either if there it is not already occupied by something else. Okay, so basically while we are doing that, uh, it can, if there is no obstacle, it can easily reach to that point, that is the our exact point. But when it cannot reach there, we have to observe this thing now. So basically if we write this and this, now can you tell me, can it reach to the our destination or not?
No, Bhaiya.
Yes, so it cannot reach to its destination now. And now if we do this, now can you tell me if it can reach its destination or not?
No, bhaiya.
Okay, so now tell me, can it reach its destination?
No.
Okay, again tell me, can it reach its destination?
No,
Hello.
bhaiya.
No, no, Bhaiya.
Yes, so can you observe anything that what we are actually doing, in which cases we are getting that it will not reach to that point destination?
Whenever it
Yes,
is bounded.
yes, yeah.
Yes,
When we
whenever it is bounded.
cover either
And
side of the
yes,
cross.
Shubham, you are telling right, and it is the thing that how can we tell that it is bounded or not? So basically, it will be bounded if, let's say, there is an cross x. If we start exploring from this point, you can say if we do BFS traversal from this x value, and we'll only traverse the cells which are occupied, and if it makes a path that joins to either this thing, either this column, or either you can say this row, if it join to this, either this column or this row in any manner, then it will be bounded. or you can say also from if it starts from this, then also basically uh, can you see now that if we only try it from for these cells only, these cells, let's say if we show you by another color, if we just try for these cells and these cells, okay, and for these cells if we do that BFS or DFS traversal, and if we check that if the cells are reaching either in this row or this column, if it reaches in this row or this column, then it will be bounding any of the either destination or either the starting. Is it clear?
Yes, yes.
So now what we'll be checking, we will be checking only for this let's say up to at most what will be the row size 2 into 10 to the power 5, and what will be the column size 2 into 10 to the power 5. So basically at the maximum we will be checking for 2 into 10 to the 4 into 10 to the power 5 elements, and that is okay for us because uh, before we were checking for 10 to the power 10 order of elements. Now we have reduced that thing to just this amount of you can say elements, that we have to just check for these elements, that if we start from this thing, can it bound either the destination or the you can say starting point. So basically now if we do the BFS traversal from any of these points, you can say, so uh, what will be our destination, you can say, what will be our movement type, how can we move, can you tell me? Can you can say, let's say this is our box, uh, what will be our movement type, this or this, can you see now?
What type? Okay.
Okay, so basically it will be tough for you to recognize what type of thing, or you can say what type of movement we have to choose here. So basically it is the catch here that we have to choose this type of movement here, okay, and this was the main problem in that question, that we have to figure it out, that we have to check it, we have to do the DFS traversal by this, that we can go up, down, left or right, and also we can go diagonally. Is it clear?
Yes, yes.
Because if we see if we make you see that uh, let's say we are getting rid of these things, just this, okay, can you see now, can you tell me that is it be going to the destination or no, not, can it go
Not
to its destination? Yes, not possible because it cannot go diagonally, okay. So basically if we make a diagonal you can say uh, okay, bounded thing, that is, let's say all the x are at its diagonally connected, x also, then also it is bounded. Is it clear?
yes, yes.
So basically now from this thing you have to observe this, that you can go to either diagonally and right, up, left and down also, okay. So you can move any in any direction basically here, and we have to check that if it reaches to either this side cells or either this side cells. If it reaches at any of these cells, then we can tell it surely that it will not reaching that the starting point cannot reach to the ending point. Is it clear?
Yes, yes.
So now can you tell me how we can code it?
Uh, no, yeah, but we can use to array for the diagonal movement and the upward and the like all direction movement, storing the indices of like upper and all sides,
Yes,
and
yes.
then we can
So
move.
basically you have done the DFS and BFS traversal, na?
Yes, yes.
So let's say in DFS traversal, what you do, you can say if it is your BFS thing, that first you have to you choose I plus 1 j for this BFS I comma j plus 1, and for BFS you can say I minus 1 j, and you can say BFS you see I comma j minus 1. Okay, so you know this thing na.
Yes, sir.
So basically, in normal BFS, you traverse for this four way, but in this case, we can traverse to that diagonally. We can move diagonally. Okay. So what we will do? We will just keep this thing. We can do I plus 1 comma j plus 1. We can do BFS I minus 1 comma j minus 1. We can do BFS I plus 1 j minus 1. We can do BFS I minus 1 j
A
plus
plus
1.
one.
Okay, so basically we can move in 8 direction. Is it okay now for you?
Yes, sir.
So basically we will go to the each you can say the each crossed. Let's say we are storing it in a set, or you can say or map, anything you can tell. Let's say we are storing it in a set that is the pair of I comma j. Okay. So for each thing we have to check, and this is storing that cells that are you can say occupied by obstacle. So now we will traverse to the set, and we will check if this thing or this thing, if it is exist in this case, in this line. So either it's j is you can say if it is zero based 0 1 2, let's keep it zero based for your understanding. If it is j equals to 0, or if I is n minus 1, then what we will do, we will just do the DFS for I comma j, and there's that DFS thing, it will give us that if it reaches to either this row or this column or not. Is it okay?
Yes, we have. But
So
we
can
check
you
the minus one layer, like
what?
some for bound cases we use minus one, j equal to minus one and I equal to.
Yes, j for this thing, for this, no no no, you are doing right. We will checking this thing that I is equals to 0 or j is n minus 1 in that DFS case, in that DFS. Okay, I
Okay,
am telling you that we have to start from a cell na. We have to start from a occupied cell, then that the
understood.
cell values, that is we will be giving so let's say we are giving input as h comma w comma k, and we will be giving that ri and ci dot 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 rk comma ck, and we will be putting these values, these pairs in the set. Okay.
Okay,
So these are the thing that we have to check it for that, and what I have said you, that we have to check for this line. We will start checking for this line elements. So basically we will iterate through the set, and we will check if the pair I comma j, it is this, if it is the cell belonging to this thing, this part or not. If it belongs to this part, then we will do the DFS. Okay.
okay, wait.
And in that DFS we will check that it is going to that thing, that is it is going to this row part or this column part. Is it okay now?
Okay, wait.
So basically in the DFS part code, what it will look like, it will look like that this is our traversal part, that this thing, and our you can say if uh, I is equals to this, for this thing I is equals to 0, or j is equals to n minus 1, then we will just keep a flag. Okay. flag was true, and we will just return. Okay, so this flag, this will, if this flag remains true, then what we will do, we can just print at that part that we will not reach to the destination. Is it okay now?
Okay.
Okay, so can you tell me now that how the total code will look like?
No, we have like graph portion is
Okay,
very good.
yes. This must be tough for you. So basically, I will show you that code. Then you will get the whole idea that how you can implement it. Because the main thing is that you have to implement it, and it is the toughest part here. So just see there. Okay. So there I have done the BFS traversal. Okay, I have not done the DFS. So basically, uh, see
And
that
that
we are
code is
taking
not
input.
visible.
Okay, sorry. Uh, okay, now is it visible?
Yes, yes.
Okay, so now just see, we are taking input H, W, and K, and we are making a set of pair, that is S, and we are making a map. Okay, we are creating what the map does. Map is same thing as we can say we take the visited arena in that traversal. So the
Yes,
map does the same thing here also. So now what we will do, we will just take input of the I and j values of the obstacled cells, and we will put it in this set. Okay, and if we see that, you can say, I think I have done it in one based indexing. So basically in that, so I have shown you as zero based indexing, but don't worry about it. Just in that one based indexing, you have to just replace 0 to 1 and n minus 1 to n, and nothing another else. And what here you will do, you will now just check if the starting element, or you can say the starting cell or the ending cell, if it is in that set. Yes. So what does it mean? It means that it is it occupies by an obstacle. So if the starting or ending point is itself is having obstacle, then we cannot start our journey, and you cannot reach to your journey. Is it okay?
yes, yes.
Okay, so basically now what we will take, we will just take a flag variable that we will initialize it by false. And now just I have said you that we will just iterate over the set, and while iterating, we have to check that if the uh, row value is 1 or the column value is h. Okay. uh, Basically I think I have done it in the opposite manner as I have mentioned you. Basically, so I have mentioned you that I have started from the down part and the left part, and I have go to the right part and upper part. Na?
That's good.
Yes, but in that code I have just done opposite. I have just done I have started from the upper part and right part, and I have gone to the down part and the left part. It is the only difference, and nothing is different from that. If you see that, now what I have done here, I have just pushed it in the queue as the normal BFS traversal, and make the map as true. And same there, we have popped it out, and then we have take the neighbors. Okay, so these thing, as in the BFS traversal, you see now that 8 lines of code, that how you can proceed. So this is the thing that the neighbors array, it is stored for you, that what are the possible destinations for our for our for from that cell. Okay, so for each cell that can be our destination, we will check if it is inside or outside the grid. If it is inside the grid, then we will check if it is inside the set. Because if it is inside the set, that means that it is occupied by an obstacle, and we can traverse through it. Okay, so if it is inside the set, and also if it is not inside the map, that means we have not traversed it yet, then and then only we will make it mark it true in the map and push it into our queue. Okay. And uh, after this thing all you can say all this thing what they're the main part of our you can say of our code, that is where our flag, that is our is getting the true, then that time we are breaking it out. Okay. So basically what is happening here, basically uh, there we are iterating over the whole, you can say the whole uh, array, that is the grid. And if this thing it is you can say the flag, that variable it is getting the true, then you can say that we cannot reach to the destination. And if it is not true, if it is false, then we can reach to our destination. Is it okay now?
Yes, yeah, okay.
Okay. So if any query, so you can tell me also now. But for now, is it is all for today. So if you have any question related to your uh, coding journey or CP or anything, you can ask or you can leave now.
But yeah, I have a little issue on topic. I mean, like when we